In this example, we will use bisection method in finding the value of x that lies in the interval between 0 and 2 for the function fx is equal to x times sine x minus 1. For the initial value of the endpoints, for the left endpoint AO is equal to 0 and for the right endpoint BO is equal to 2. In the iterations, for the midpoint CK, we let K as the number of iteration. CK can be determined by adding the left endpoint AK plus the right endpoint BK divided by 2. To have a good presentation of the solution of this example, I will use Excel program. Before we have to find the value of x, we need to see what this function looks like. So I have here the values of x, and this will be the values of our function in terms of x. Okay, so let's say if our x is equal to 0, so our function will be equal to x times sine x minus 1. So here, this will be the value of x. So I have here equal to 1 plus 0. So I need to write the formula in order for me to drag the cell. And this will also gives automatically the values of the function of x. So here, from here, I need to plot this. Okay, insert, then all chart types, then I will use scatter plot x and y. Okay, so this is the function looks like. But in the problem, we are only to evaluate the value of x between 0 and 2. So we only have to focus at this interval. Okay, so next we have to evaluate this value of x between 0 and 2 using bisection method. So I have here, this is my k for the number of iteration. Then let's have here the left endpoint. So I have to write here left endpoint. So this will be my AK value. Then for the midpoint, this will be my CK value. Okay, I have to drag this because the width is very small. So we have here the right end point. So this is PK. Okay, I have to drag it again. Okay. Then this will be the function of AK. Then function, the values, the column for the values of BK, function BK, and the function CK. Okay. Okay, so now I have to input the values. Okay, so here, this is the number of iteration. So I have to put this 1 plus the cell equal to 0. Then I have to drag. It's up to you if how many iterations you are going to use. Then for the left end moment, since our interval is from 0 and 2, so I have to write here 0 for my left endpoint. Then for my right endpoint, I have 2. Then since the midpoint CK is equal to the sum of the left endpoint and the right endpoint, then you have to divide it by 2. Okay, so I have now my midpoint. Okay, we need to find the value of FAK, so this will be equal to, okay, that is left end moment times sine, okay, minus 1, that is equal to negative 1. Okay, I have to change this to CK and BK. Then here, this is equal to the midpoint times sine. Okay, double click, then minus 1. Okay, then here, this is for the right endpoint times sine. Okay, double click, minus 1. Okay, so I already have the values for the function. So I need to set the number of decimal places. So it's up to you how many decimal places you are going to consider. But here for my discussion, I only have to use 6 decimal places. But here, this is the number of iteration. Okay, so next we need to evaluate the location of the root of our function. So we need to evaluate the sign of the function FAK, FCK, and FBK. So since the sign of function AK and function CK, they have the same sign, so the root does not lie between A and C. So the sign of FCK and the function BK, they have opposite signs, so the root lies between C and D. So our new left endpoint will be C, and our right endpoint will still B, which is equal to 2. So we can drag this and also this one to determine the new value of the functions. Okay, so we already have the values of the functions. So again, we need to evaluate the sign of the functions A, K, CK, and BK. So functions AC and CK, they have opposite sign. So the root lies between A and C. So our new endpoint will be the value of A. And for our left point will be the value of C. So we can drag this again. Okay, we can drag this again. Okay, so here the values of the functions A and C, AK and CK, they have opposite signs. So still our left endpoint is A and the right endpoint is equal to C. So we can drag this again. Okay, so still the root lies between A and C. So our left endpoint is A and our right endpoint is the value of the midpoint, which is C. So we can drag again. Okay, so here the function or the values of the function C and B, we have opposite signs. So our new left endpoint will be the value of CK. And the right endpoint will be the value of CK. Then you can drag this again. Then drag and drag and drag. So again, function CK and DK, they have opposite signs. So we will use the values for C for our left endpoint, and for our right endpoint will be the value of B. Okay, so you can drag again. We will stop if the function of C is equal to 0, but still the function of C, since we consider 6 decimal places, so we need to make all of this equal to 0. Okay, so still they have the same, they have opposite sign. So this is our left endpoint, and for our right endpoint. So you have, okay, so you can drag and drag and drag. Okay, so again, the value of FAK and CK, they have opposite signs. So we have for the left endpoint, we have the value of A. Then for the right endpoint, will be the value of C. Okay, then you can drag again. And drag. Okay, so since again we have new value of endpoint, we have C for our left endpoint, and for our right endpoint, it's the value of B. Okay, so next we have to evaluate again. So the value of AK and F and CK, they have opposite sign. So this will be, for the right end, is the value of C. Or maybe you can drag also here. Then we'll have to change the, okay. So again, we have here opposite sign for our FAK and CK. So this will be equal to A, then the value of the right end is the value of C. Okay. So this will, once you drag this, so it gives automatic the values of the functions CK. Okay, again, so here we have opposite sign. So we have for C for our midpoint, and B for our right end point. Okay, so here they have opposite signs. So this is for the C value, for the left endpoint, and for the right endpoint, it's the B. Okay, so we can draw. Okay, we're almost there. So we have 0 again. We have C value for midpoint, for the new value of the left point, which is the value of our CK. Then equal to the right endpoint is the value of P again. So that will be the value. Okay, we're almost there. Then, so okay, we have A value for the right end, and we have the C value for the, no, A value for the left end, and the B value for the right end. Sorry. Okay, so we also have, okay, we have to add our iteration. Okay, we'll try 20 iterations for this, because we consider 6 decimal places. So we need to make all of this the function of C equal to 0. So we have here opposite sign. So this is your left endpoint, and this is your right endpoint. Okay, we're almost there. So again, we have another. So this would be for the left endpoint is the C value, and for the right endpoint, the value of B. Okay, so we have 0.00002 for the function of C. Okay, so again, we try. So this for the right end. Okay. Okay. Almost. We already have the values of 0.00003. Okay, so this would be our new value. So you have C for the left end and B for the right end value. So okay, so 0.001. Okay, so we have C value, and here we have for the right hand value. Okay, so that is 0.001. We will add last. Okay, we will add three iterations. We will try to see. So this will be the value for the right hand moment and C. We will check if there are some changes. Okay, so for 21 iteration, we already have 0, 0 point. So for the function of C, so we have here, if we try to make everything of the functions equal to 0, so we will have here for the right end moment, left end moment, and okay, we already have 0, 0, 0. Then we have negative. This will be the last one. Okay, but if we try to use 7 decimal places, it's not equal to 0, 0. But here in our discussion, we only have to use 6 decimal places. So at 21 iterations, we got FC, the function of FCK is equal to 0. So we can say that the value of x, or the root of this equation, is equal to 1.1141415. So 1.114157. So this is the answer. Okay, so if we are going to check or we are going to plot these results, so we will try. So okay, we have insert, scatter plot. Then you have to go to select data. We have to remove this one. So we have to edit. So you can write series name, or here I want to. Okay, you have to put comma, then another comma. Okay. So for our values of y, we have our function. We have here, then comma, comma. Okay. So We need also to edit the axis. So for the y-axis, so I have here, because we consider 6 decimal places, so I have to put it 0. So make it whole number. Then here, okay, so I have to delete. Or if you don't like to delete the series, so maybe you can say, okay, edit, so function of x. Okay, this is. Okay. Then if I try to connect all the dots, so I will go here. So for the perfect, you have to find the perfect fit. So third degree is okay. So okay, so this is my function. I can delete also that one. So if you are going to check this function or this evaluation is for the interval of 0 and 2. So you can have this one. So here it's the root of this function is equal to 1.114157. Okay, so again, I hope you understand, and thank you for viewing this lecture or this video. Thank you and God bless.